All right, so we're going on page 48 for this one. This is rational exponents, meaning they're fractional exponents. That's another way to say it. Fractional exponents. So they are simplified. If you're told to simplify or evaluate, no negative exponents, no fractional exponents. Well, that's if you're told to put it in radical form. We still might have that. No complex fractions. No, we can't have a fraction within a fraction. None of that. The index of any remaining radical is the least number possible. Least number possible. The base is always written with the smallest number possible. Okay. So here's what we have. We have rational exponent form, m over n, and then that's what it looks like in radical form. So if I just had like 7 to the 1/2 power, like it has right here, you know that that is the square root of 7, right? But if there's that, because there's just a 1 in the numerator, if there's another number up there, that becomes the exponents either inside or outside the radical. So the denominator always tells you the index of the root, and then the numerator is the exponent on whatever it is we're putting inside or outside the root. Okay, so 3 to the 3/4 power is the same as the 4th root of 3 cubed, or, you know, you can write it either way, basically. Whichever one might be easy, and it doesn't matter. So if you're trying to take the cube root or something, a lot of times it's easier to take the 4th root of something before you cube it so your numbers don't get giant. That's an option there. But we can also deal with the fractional exponent. Sometimes that helps us out greatly. So here is, we have 2 different methods we can look at. Change the base to a radical form. So I could take this here, and I can rewrite this as the cube root of 27. And then I can either have 27 squared under the root, or it could be outside. In this case, I think I want it outside because I think I'd rather take the cube root of 27 first. So what is the cube root of 27? What times what would give me 27? 3. Okay, so this would be 3 squared, which in the end then gives me 9. Okay. You can skip the root form altogether if you want, because method 2 is change the base. So the base is 27, change that to the smallest number. So I'm trying to figure out, like, what to what power could I make this? Well, in this case, we know that that would be 3 to the 3rd power, and then all of that to the 2/3 power, right? And when you take a power to a power, you are multiplying. So when I multiply this, I would get 3 to the 3 times 2/3 power. What's 3 times 2/3? 2. So this is just 3 squared, which is 9. And of course, you could skip maybe this step right here, writing it like that. I just want to make sure I don't lose anybody. So either way works, okay? And then you can kind of decide, even if you're told to do it in a, like, leave your answer in a certain form, you could still work it in whatever form you want and then convert it to that form in the end. All right, so let's look at this next one. We've got 32 to the 3/5 power. So I can rewrite that as the 5th root of 32. And then I'm thinking I don't really want to cube 32. Thinking I probably want this on the outside, like that. Okay. So what is the 5th root of 32? 2. Okay, so 2, 4, 8, 16, 32. So that means that this gives me 2 cubed, and what's 2 cubed? 8. Regardless of which way you do it, you still basically have to take the 5th root of 32. That's what you're doing when you get the smallest base here. 32, like, I can't take the square root of 32, so it's not like I can even do anything there, but we know that it's 2's here. So I'm going to get 2 to the 5th to the 3/5 power. And then when I multiply 5 times 3/5, because I'm taking a power to a power, this becomes 2 cubed, and that gives me 8. So you're really doing the same process, but sometimes it's actually easier to deal with the fractional exponents first. All right, so then I have 81 to the negative 1/4 power. So that's really the same thing as 1 over 81 to the 1/4 power, right? Which is the same as 1 over the 4th root of 81. So I'm pretty sure I'm not using 2's here, right? Because that's an odd number. So what times what times what times what would give me 81? What would be a good guess? 3. Okay, so 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is just 1/3. Now, if you are doing, it says change the base to the smallest number, you could make that 81 9 squared, right? I mean, that works, but that's not the smallest number, so I can't use just 9 squared, but you can always do that and then do it again. Let me show you what I mean. If I can say, okay, I know that that is 9 squared, so that's going to be to the negative 1/4 power, right? So that means I'm going to get, when I multiply 2 times the negative 1/4 power, what does that give me? What's 2 times 1/4? 1/2. So this would give me 9 to the negative 1/2 power. And then I know 9 can be 3 squared. And then I can multiply it and then to the negative 1/2 power. So that's just going to give me 3 to the negative 1. And that gives me 1/3. So that's just doing it in steps. Now, could I have gone straight from here to 3 to the 4th? Absolutely. But if you're not sure what to do a little bit and be like, hey, that's still not the smallest I can make it. I can do a little bit more. And then you're still going to get to the same answer in the end. So it's kind of whatever makes the most sense to you. Okay. What questions do we have? Anything? You have a question? Ask me a question. You're such a liar. What's your question? Okay. All right. So let's see. Now, is 16 the smallest base we could possibly have? No. Okay, but I can go ahead and deal with the exponents. We're going to work some of these more than one way, just because it kind of depends on, you know, what you see when you go into it or how the question works out. When you multiply something with the same base, what do you do with the exponents? What is x squared times x cubed? You all know this question. Yeah. X to the 5th, right? You add them. So that means this I can rewrite as 16 to the 3/4 plus 1/2 power. Does that make sense? And then in order to add them, I have to have a common denominator, so I need to change this 1/2 to 2/4. So that means this gives me 16 to the 5/4 power. Now, 16 is not the smallest base I can have. I know that the square root of 16 is 4, and then the square root of 4 is 2, which means that 16 is actually 2 to the 4th power. So 2 to the 4th power to the 5/4 power. Then since I'm taking a power to a power, I'm not adding those, I'm multiplying them. What's 4 times 5/4? 5. So that's 2 to the 5th, which is 32. Okay. Another way we could look at this is you can go ahead and deal with this. What's 16 to the 1/2 power? 4. Isn't this just another way of saying the square root of 16? So I could say here, or we could do this because you wouldn't have to do all of them. But if you know that this right here gives you 4, so now we have 4 times 16 to the 3/4 power. Does that make sense to you? I could go ahead and simplify that right there if I wanted to. That way I wouldn't have to add my fractions. I mean, it just eliminates that for me. Then that could give me 4 times 2 to the 4th power to the 3/4 power. Then 2 to the 4th to the 3/4 is 2 to the 3rd is 8. Yeah, so it's 4 times 2 to the 3rd. I just want to make sure I don't lose anybody on where this stuff came from. 4 times 8, which is 32. Everybody good so far? Questions? Okay, so I'm going to take you back up to the top, and let's talk about something we did with roots. And then we're going to work that actually one more way, because different things are going to pop up at different times for you. If I have the cube root of x to the 7th, okay, just write that up there, cube root of x to the 7th. And we wanted to simplify that. Remember, we take the exponent on the inside and we divide it by the index, right? How many times does 3 go into 7? What? 2. Did you say none? Yeah, none. Okay. Okay. Basically, I'm putting 7 over 3 here, right? 7 over 3, and so 3 goes into 7 twice, so an x squared comes out. How many do I have left over? 1, and so x to the first stays inside. That's how I reduce that. Does that make sense? You remember that? Talked about that the other day. Okay, so instead, if I just start, because I'm doing 7 over 3 anyway, if I have x to the 7/3, and it's not in root form, but if x to the 7/3 there, I can do the same thing. 3 goes into 7 twice, so that means I can take out an x squared, and then 3 goes into 7 twice with 1 left over, x to the 1/3 power. Okay, so you can reduce your fractional exponents that way. Okay, what questions do you have about that? Okay, so thinking that way, we go back down here, and let's start right here. I'm going to put this right here. Or when I get 16 to the 5/4, like when I get to that part right there, I can simplify this before I do anything else there. So 4 goes into 5 once, so that means 16 to the first comes out. You can put a 1 there if you want, you don't have to. And then there's 1 left over, so that's times 16 to the 1/4 power. So this was unsimplified completely. This was simplified a little bit, and then this is kind of simplified even more. So now I just have the 4th root of 16, which is 2, and that also gives me a 32. So you have lots of options here. Which one is the best? Whatever makes the most sense to you at the time, or whatever you may feel like is the easiest with the numbers that you were given for that question. Okay? So we won't work all of these multiple ways, but I think the next one I wanted to work 2 different ways as well. Okay. What questions do you have? All right. So now let's look at number 2. On number 2, I can't combine those yet because the bases are not the same. But I can make this into 4 to the negative 3/2 power times, I left it back there. I wasn't sure if it was yours or not. So. 4 to the negative 3/2 power. And then I can make this a base of 4, saying this is 4 squared to the 1/4 power. So this becomes 4 to the negative 3/2 times 4 to the what? What's 4? When I multiply the 2 times the 1/4, what do I get? 1/2. So then I can combine these, right? And I can say that gives me 4 to the negative 3/2 plus 1/2 power, because I add my exponents, right? Negative 3/2 plus 1/2 gives me negative 2/2, which is really just negative 1. And then that gives me 1/4. Okay. Any questions about that? We know our exponent rules, right? The negative puts it in the denominator. Did we already go over those? Do we need to go over those? Angel, take out your earbuds, please. We could have gone all the way down to the lowest base, which is what you would need, especially if I had any roots left. I could have rewritten this. I think this is the last one. I'm going to do 2 different ways. But I could have done this 2 squared to the negative 3/2 power times 2 to the 4th to the 1/4 power. This gives me 2 to the negative 3 power times 2 to the first. Then when I combine them, I add my exponents. So that gives me 2 to the negative 2 power, which is 1 over 2 squared, which is 1/4. Okay. What questions do you have? Everybody okay with all that? Yes? I'll take that as a yes. All right. So I need to get the same base here. I can rewrite 8 as 2 to what power? Third. 2 to the third over 2 to the 3/4. When I am dividing two terms with the same base, what do I do with the exponents? Subtract them. So this becomes 2 to the 3 minus 3/4 power. What do I need in order to subtract? Common denominator. What would my common denominator be? 4. So this is going to be 2 to the 12/4 minus 3/4 power, which gives me 2 to the 9/4 power. Now let's think about how we can reduce this. Okay, my fractional exponent is greater than 1. That means I can reduce this sum. How many times does 4 go into 9? 2. So that means 2 squared gets to come out, and then 2 to that, how much is left over? 2 goes into 9 twice with 1 left over to the 1/4 power. So this becomes 4 times 2 to the 1/4. Or, and it doesn't tell us which way to do this here, or it's 4 times the 4th root of 2. This is rational exponents. That is radicals. Okay. What questions do you have? Anything? Okay. Somebody else still writing. Let me get the tea. All right. Flip it over. Now we have variables with fractional exponent, well, and a number, with fractional exponents, and we need to put it in radical form when we're done. In order to do this and get these all under the same radical to simplify it, we need the same denominator. Okay, so we have to get common denominators with these right here. Of these three fractions, what would my common denominator be? 6. Okay, so this is going to become 4 to the 2/6 power times a to the 15/6 power times b to the 5/6 power. Do you agree with all that? Okay, so now I can put it all under one radical. This is the 6th root of 4 squared times a to the 15th times b to the 5th. Right, because that denominator is the root. So now I have that left. Then I always have to try and simplify what I have. If any of these are greater than 6, then that means something can come out. The only one that's an exponent greater than 6 is the a. So this is going to become the 6th root. Ooh, well, no, I need room there. You leave myself a little room. 6th root of, well, 4 squared is not going to come out, so that's just 16. 6 goes into 15 how many times? Twice. So that means a squared comes out, but it doesn't go in there evenly. So how many are left over? 3. 3 are left inside, and then b to the 5th. And this is my answer. What questions do you have? All right. Now, let's look at this one. I want to simplify this. So this is going to become, since that is a negative exponent, I can rewrite it as 1 over x to the 2/5 power. But I cannot leave a fractional exponent in the denominator. That's like leaving a radical in the denominator. totally mathematically illegal. Do you remember, I think it was yesterday, when we had, like if I had 1 over cube root of x, we had to multiply that by the cube root of x squared over the cube root of x squared so that we could get the cube root of x cubed in the denominator, and it became 1, right? That's because we were trying to make the exponent be 1. It might be a little bit more obvious here. Now remember, when you multiply, you're adding the exponents, right? I cannot have a fractional exponent in the denominator. So what can I multiply this by to get 1? If I'm going to add the exponents, what do I add to 2/5 for that fraction to become 1? What? 3. 3 what? 3/5. So if I multiply by x to the 3/5, now remember, this has to be a value of 1 because I'm not changing the value, I'm changing the way it looks. So when I do this, and you can skip part of this, but I want it in your notes so you remember where it came from. This becomes x to the 3/5 over x to the 5/5 because we're adding the exponents, right? And since that's x to the 5/5, that's really just x. So you get x to the 3/5 over x. Okay. And so this is the part you could like skip when you're actually showing your work, and that's fine. But again, I wanted to make sure you knew where it was coming from and why, what was happening. Now it says place it in radical form. Those were my instructions. So my denominator stays x. This is the 5th root of x cubed. And that's my answer. Ask me a question. No, go ahead. Is that the same question? No. Okay. What's your question? Okay, no. So I had to, this you have to come up with. You have to come up with this. It's kind of like if I'm going to rationalize this denominator, you have to come up with what this is, right? So what I came up with, I needed to make it into 5/5. So what do I add to 2/5 to give me 5/5? I add 3/5 because when we multiply, we are adding the exponents. Does that make sense? So you have to come up with this. That's on you, right? And it's whatever the rest of the fraction is to make it 1. That's what we're coming up with. Does that help? Okay, good. Any other questions? I'm trying to think. I know we have a few more that are coming up like this. Are we all good so far? Okay. So I was actually going to work number 6. Actually, I am going to work number 6 differently because number 7 is going to work out kind of like that where we have to come up with that. But we came up with that. And this is legal because this fraction is a value of 1, right? The fraction itself is 1 because it's the same thing over the same thing. So we're not changing the value, we're just changing the way it looks. Okay, we good? All right. So then this says we want it in simplified rational exponent form and radical form. So the way in which you work it is up to you. If you want to make that into the cube root of 2 and rationalize the denominator because that's what makes the most sense to you, that's fine. But we already have it in rational exponents here. So why not just do, like this is 2 to the 1st, right? And if I'm dividing, I'm going to subtract exponents. So this is 2 to the 1 minus 1/3 power. So what is 1 minus 1/3? 2/3. Yeah, very good. So this gives me 2 to the 2/3 power. I don't have any fractional exponents in the denominator. 2 is the smallest base I'm going to get. I think that's, as far as rational exponent form is concerned, that's the best I can do. So it tells me rational exponent form and radical form. So then this also equals the cube root of 2 squared, which is the cube root of 4. Okay. What questions do you have? All good so far? All right. So then on 7, this is going to put this down in the denominator again. So this is going to become 1 over x to the 4th y to the 2/3 power. Now, I could distribute that exponent, but it's going to be easier for me not to at first. But because I have a fractional exponent there, I have to get rid of that fractional exponent. So I have to multiply by a fraction that has a value of 1, and it's going to be x to the 4th y, and then what power do you think is going to have to go on there? 1/3, because it's what I have to add to 2/3 to get that to a 1. You with me on that? That's how I know. So if this is 1/3, then the numerator has to be exactly the same, just like that. So I had to decide it was to the 1/3 power because I'm rationalizing the denominator. And these two fractions, when they add together, I want it to have a value of 1. Okay, everybody good on that? Okay, so then I'm going to move forward, and I can make this, I can go ahead and distribute this exponent because there's no addition in there. So this becomes x to the 4/3 times y to the 1/3 over x to the 4th y, because all that just becomes to the 3/3 power, which is the first power. So we can just, the whole reason we did it was to get those fractions out of the denominator. Everybody good so far? Okay, now can I simplify the numerator a little bit? I can simplify the x, right? So if this x to the 4/3, how many times does 3 go into 4? Once. With how much left over? 1, so x to the 1/3, because there's 1 left over, times y to the 1/3 over x to the 4th y. Can I reduce that a little bit? Yes, because I can cancel this x out with one of these, so that becomes to the 3rd power. So my answer then will be x to the 1/3 power, y to the 1/3 power over x cubed y. Ask me a question. Anybody? Okay. I also have to put it in root form, right? So another way I can write this is xy to the 1/3 power over x cubed y, which means this is the cube root of x times y over x cubed y. And which form is better? Really just depends on what your directions say or what you are using it for. This would be an acceptable version of that as well. Either way is fine. What questions do you have? Well, good. All right, so let's look at number 8. I think I'm going to start by, well, I'm going to wait on that negative exponent because here's where I cannot just take this and stick it in the denominator because there's addition there. If everything's being multiplied, I can move things around like that, but with that addition, I can't do that. So instead, I'm going to start by rationalizing the denominator. So what am I going to have to multiply by? X to the what power? 1/3. X to the 1/3. Okay. And since this numerator has 2 terms in it, I'm going to put parentheses there. Because I have to distribute that x to the 1/3 power. So this becomes, when I distribute that in the numerator, I'm going to get 3x to the negative 1/3 times x to the 1/3 plus x to the 5/3 times x to the 1/3. Okay, you see how I just distributed that in the numerator. And then in the denominator, I'm just left with x. Everybody okay with that? In the numerator then, when I start to simplify, and I'm not skipping any steps, I would suggest most of us probably shouldn't, just because we can do weird things then. This is going to give me 3 times x. Well, what's negative 1/3 plus 1/3? Negative 1/3 plus 1/3? 0, right? 0 plus x to the 6/3 all over x. Okay. So what is x to the 0 power? 1. So this whole thing doesn't become 1 because it's only x. It's 3 times that, so it's basically 3 times 1. So that is 3 plus x. What is 6 over 3? 2 squared over x. Now, can I cancel the x with the x squared? Can I reduce that? No. It's a hard no on that because there's addition up there. Okay, if it was multiplication, that's a different story. But that addition, because I can't do all 3 terms don't have something in common, I can't do anything, and that is it. And that really, I know it says in rational exponent form and radical form, but there's not a radical there. So, I mean, there's not a fractional exponent, so we don't really have more than one form. I don't think you had to, but if you didn't, I don't know what happens. The bookkeeper, you just go to the bookkeeper. Do you know where the bookkeeper is? Did we have that discussion? I had that discussion in one class yesterday. Was it in here? We were confused about the bookkeeper / the book room. Okay, just so you know, the book room, like where we picked up our calculators, that is not the bookkeeper. That is the book room, textbook room, but we don't even use textbooks anymore. But the bookkeeper is in the front office, close to the APs. All right, one more here, last one. So here I have fractional exponents, right, in the denominator, which is bad, right? The other way I could write this is I could write the denominator as the square root of 6 plus the square root of 2. Do we agree with that? It would be the same thing. Okay, but we're going to leave it in fractional exponents. And we are going to multiply by the conjugate. So the conjugate of that would be 6 to the 1/2 power minus 2 to the 1/2 power. And I'm going to multiply numerator and denominator by the same thing. Okay? Anything with 2 terms, I'm going to put parentheses around. In the numerator, although I could distribute, I'm not going to just yet. I'm going to leave that as 2 times 6 to the 1/2 minus 2 to the 1/2. This is a difference of squares, right? So I square the first term. 6 to the 1/2 power squared would be what? Think about that. 6 to the 1/2 power squared. What's that going to give me? 6, okay, over 6. And then if I take 2 to the 1/2 power and square that, what does that give me? 2. 6 minus 2. So then this becomes 4, right? 6 minus 2 is just plain old 4. Now, I cannot reduce this 4 with this 2 because that makes no sense. And there is subtraction there, but this is multiplication. Basically, that guy's factored out. So he can reduce with this, and we end up with 6 to the 1/2 power minus 2 to the 1/2 power over 2. Now, if I could get 6 and 2 to have the same base, I would need to do that to combine those, but I can't. Like, if it was 8 and 2, that'd be different because I could get them to both have a base of 2, but I can't get those bases to be the same. So this is my answer. And then in radical form, it is the square root of 6 minus the square root of 2 over 2. Those are my 2 different forms there. Okay. What questions do you have? All right.